Well, hello, 3C. We are going to be talking about quadratic relations today. That is our topic, quadratic relationships. Our goal? I understand the properties of a quadratic relationship and I can recognize them in real-life situations. Okay, so quadratic relations. This is what a quadratic relationship looks like. And this is one of the easiest to visualize. It's a projectile. It shows, as time passes, the projectile, now I hope you know what I mean by a projectile. A projectile can be anything from a rocket to a bullet to a ball to a paper airplane, anything like that. And you can just sort of really see and hear what goes up must come down. And that is sort of the whole mantra here for quadratics, is that it first goes in one direction and then it gradually changes over and goes the opposite direction. So here we have the height of a projectile versus time. So I'm going to try and transfer this graph into a table of values. So the first thing I'm going to do is pick some points here. And let's get kind of a bigger line. Okay, what I'm going to do is I'm going to go along and I'm going to put some dots on each of the times. So at 1 second, it's here. And at 2 seconds, it's here. And at 3 seconds, here, 4, 5, 6, 7, 8, 9, and 10. And there's one thing that I want you to notice about a parabola is that it's symmetrical. Look here at 0 and at 10. The dots they're at 0, at the 0 mark. Up here at 1 and at 9, they're also at the same spot. Look at that. It's symmetric. They've got, and we have a middle point here, right up here. We got that middle point there. So let's have a look. I'm going to estimate these numbers. In fact, I'm going to do a little more than estimate these numbers. I know what they're supposed to be exactly. So I'm going to write them in this chart over here. At time, oh, I missed time 0. At time 0, it's at height 0. And at time 10, it's at height 0. Okay. At time 1, it's at height, this is actually 45. And at 9, it'll be 45 as well. So 45 and 45. At 2, that up there is actually 80. You have a look at that, 80. And we see that height again over here at time 8. That's also 80. At time 3, that is a little more than 100. It's actually 105. And this is 105 down here at 7. See? Same thing. They're across from each other there. At time 4 and 6, they're up here. That is actually 120 right there, if you have a look at it. And then this one's easy to see. At time 5, we're right at the tip of it, which is at 125. Now, so you can see when we look at the chart, again, what goes up must come down, and there is a high point. This high point is what we actually call the vertex of the parabola. Okay, that is the vertex, and we're going to talk about that a little bit more in a minute. But we're going to call that the vertex, the top point. But I want you to see what happens here. We're going to take and subtract these things. And when I take and subtract these things, we're looking for a pattern. And if we do it to a line, we know when we subtract these things, we get a constant difference because for a line, it has a pattern, like a constant pattern up here. Here, it's not so constant. Here, what we're going to get here, 45 minus 0 is 45. Then 35. Then 105 minus 80 is 25. And 120 minus 5 is 15. And 125 minus 120, remember we're taking this first one here and subtracting the next one. 125 minus 120 is 5. And then 120 minus 125, oh, that's going to give me negative 5. And then negative 15, I think I'm seeing a bit of a pattern here. Negative 25, negative 35, and negative 45. Okay, So we didn't find a constant difference here, but if we take a look at it, we actually do have a pattern. Let's do this again. What's our pattern here? Well, this line, this goes up by a constant amount, or actually down in this case. It's going down by 10 every time. Down by 10, that's what the negative 10 means. And you're going to find this with anything that is a quadratic relationship. This second difference here is always going to be the same number. And by the same number, I mean it's not always going to be 10, but that this row is all going to have the same number as the next entry there. So I've just talked to you about this general quadratic. So here's general properties of quadratic relations. So the graph is always the same type of curve. It's always going to look similar to this. Sometimes it'll be long and skinny, kind of like that, or short and fat, I guess we could call it. And sometimes it's going to be tall and skinnier like that. But it's always going to be this general, what goes up must come down kind of shape. Or the other way around. We could flip it upside down. And we are going to talk about that. So this type of curve is called a parabola. Parabola. Not a parabola, a parabola. If you say parabola, you are putting the emphasis on the wrong syllable, and that is not a good thing. So it is a parabola. In the table of values, the second difference is see above. We just did this. This is called the second difference. Right here. That is the second difference. That second difference is always constant. Okay. This one, when we did it the first time, that was the first difference. They have a high point or a low point. Now I'm just going to switch pens at this point. I'm going to get my shape pen. They have a high point, so they could look like that. Ooh, look at that. Wasn't that neat, the way it just sort of snapped to a parabola? Or they could have a low point. And that high point or low point, and I'm just going to take my pen back here. This high point could be here. Whoops. Or the low point could be here. And that high point or low point is called the vertex. I'm just going to move these over so that it's not right symmetric about the axes. Okay, so that is called the vertex. Ooh, that's really thick. Let's pull that back down. So this is the vertex. And down here is the vertex. So it has a high point, where it switches from going up to going down. The high point and the low point is the vertex. They are symmetric. So if I put a line down the center, and visualize folding this side onto that side, or look at this point and I can go right across and there's another point at exactly the same height. It's called symmetric. If you fold along this dotted line, this one has one too. If you fold along that line, it will line up perfectly in the two halves of the parabola. Now the y value of the vertex is considered the maximum or minimum value of the vertex. Let's say that this vertex has the point -1, 3. Let's say that's -1, 3. Then this 3, because it's up here at 3, is called its maximum, because that's as high as the parabola gets. Over here, let's say this is -1, -2, this vertex point. Vertex is -1, -2. Then this -2, that's as low as the parabola gets, because the y-coordinate tells us this, tells us where it is up or down. So that -2 is going to be the min, the max or the min. Okay, now we're going to look at a particular relationship, and then you're going to look at a few more for homework. So here's an example of a real life, and I'm going to do air quotes there, a real life situation where we're going to use quadratic relations. So this says the promotions manager of a new band is deciding how much to charge for concert tickets. She has calculated that if the tickets are $30 each, then 200 people will come to the concert. For every $1 increase in the price, 10 less people will come. Create a table to calculate how much should be charged to maximize the revenue from ticket sales. Okay, so here's our situation. And there's already one filled in here. It says right now they're charging $30 and 200 people are going to come. So if they charge $30, 200 people come, and the total tickets, each ticket is $30, and we sell 200 of them, we get 6,000. Now, the situation, I'm going to go back up here. Maybe I should highlight it. I'm going to take my highlighter. It says for every dollar increase in price, 10 less people will come. So if I increase the price to $31, it says 10 less people will come. So 10 less people is 190. So now over here, to figure out how much money I'm going to make, there's going to be $31 per ticket, and I'm going to sell 190 tickets. Well, let's see what that is. 31 times 190. $58.90. $58.90. So we'll be making less money if we increase the cost of tickets. So that's not a good idea. Let's do one more increasing the cost of tickets. $32, and we're going to get 10 fewer people again. So there's going to be 180. So notice when this increases by 1, this thing decreases by 10. That's what it says. So $32 per ticket, but I'm only going to sell 180 of them. So when that happens, we're going to go here. We go 32 per ticket times 180. So that's getting even lower, 57.60. 57.60. Okay, we don't want that to happen. So let's go the other direction and see. It's very obvious we should not raise the cost of the tickets. But remember that what goes up, what must come down situation? Well, this looks like it's coming down. So maybe it went up the other direction. Maybe this isn't the maximum price. So let's decrease the cost of tickets. So let's follow the pattern the other direction. If we decrease the cost of tickets, it stands to reason that 10 more people are going to come than that 200 that we started with. So now we do 29 times 210. And what's that going to give us? Well, I'm going to pull this up and go 29 times 210 is 60.90. So that is more. But is it the maximum? I don't know. I'm going to finish off this table. You try too. I'm going to put you on pause for a second. You should put me on pause and finish off the table. I'll be back in a split second. Ta-da! There they all are. I've got them all put in there. I hope you found them too. So now let's have a look at what we've got here. We want our total money to be the biggest it possibly can be. So let's have a look when we were going back here. This is how much we were making now. And we saw that if we decrease the cost of the tickets and more people buy the tickets, that we get more money. So let's follow this back up. More money, more money, more money, more money, more money. Oh, less money. There it is. There's the biggest amount that we've got here. And notice these start to repeat themselves going back down the other direction. That's a typical quadratic relationship. So it looks like the highest point we're going to get is 6,250. So what should the ticket price be? Whoop, right there, $25. If we sell the tickets for $25, 250 people will buy them, giving us a grand total of $62.50. Okay. Now I'm going to put this information on a graph. So we're going to dual page this thing. And I'm going to put the information on this graph. So we actually have to come up with some sort of scale here. Now the lowest amount we have is 57.60. So I'm going to round that a little bit and say that the lowest I'm going to put on here is 5,500. And then the highest amount is 62.50. So I need to go up not quite 1,000, not quite $1,000 to get up there. And along the bottom, we're going from 23 to 32. So I can probably do each one of those starting at 23. So we'll start here at 23. That's 24, then 25, 26, 27. Notice I'm not writing on every single line. That will make this far too cluttered. 28, 29, 30, 31, 32, 33. And that's all we really need on here. Now I'm going to label that. This is ticket prices. Ticket prices. Now going up the side, we started at 5,500. I need to go up about 1,000 spaces. About $1,000 because this is total money. So to get up to about 1,000, if I make each of these 100, that's going to really squish it in. So I'm going to make each of these 50. So this would be 56. I'm going to go every 2 spaces is going to be another 100. So 5,600. The next one, 5,700, 5,800, 5,900, 6,000, 6,100, 6,200, 6,300. Now I'm going to take and make my pen just a little thicker again so that we have some nice dots to put on here. And I'm going to put the first couple dots on and then I'm going to pause it again, and you should probably finish it off. So for 23, we need to go to 6210. So I'm going to go up here to 62, and this would be 6250 right in the middle. So 6210 is going to be somewhere around there. Now I'm going to pause it and I'm going to put the rest of the dots on. You do the same thing. Okay, so you can see from this graph too that we've got the top point right there. Here, I'm going to single page it now so we have a look at it. There's my top point right at 62. Whoops, that's not what I wanted to do. Right at 6250. Okay, so 62. Ooh, that's really thick. 6250 is right there. So that's our top point right in there, and that is the maximum value. And sometimes you'll have a minimum if you draw it and it looks like this. You'll have a minimum value, but in this case we have a maximum value, and we can have other points in between there. So I'm going to join these with a dotted line because you don't have all possible values of ticket prices there. You can have some for $23.50, but you're probably not going to have it for 23.667 blah 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 blah. So we do use a dotted line because we have some good information in there, but not all good information because not all ticket prices are reasonable. So it looks like they should sell for $25 to give us that maximum there. Okay, so try a few of these types of questions.